If you're watching this to learn intro to networking and get all the flags, then you're at the right place. Keep watching. All right, let's go. Task 1. So it looks like we're going over the OSI model, TCP IP model, and we're going to be practicing some basic networking. All right, so task 2, we get introduction to the OSI model, application, presentation, session, transportation, network, data link, and physical. All right, so then it goes over each individual layer, and what we'll do is we'll just jump straight to the flag. I'll go over why that flag is the correct answer, and then we'll jump over to the next one. We'll try to make this quick. Which layer would choose to send data over TCP or UDP? So that's going to be the transport layer, layer 4. All right. Which layer checks received information to make sure that it hasn't been corrupted? So that's going to be our data link layer, and it's going to have different ways of checking the integrity of the frame to make sure that it hasn't become corrupted, right? So then they mention that here. All right. In which layer would data be formatted in preparation for transmission? So that's going to be layer 2 as well. It's going to be, they're going to prepare that frame to then be handed off to the physical layer, and that will go ahead and transmit it using 1 zeros. That's it, just electronic pulses, you know. All right, so next, which layer encrypts, compresses, or otherwise transforms the initial data to give it a standardized format? So that looks like it's going to be 6, which is the session layer. No, it's the presentation layer. Okay, so let's see here. It encrypts, compresses it, and transforms the initial data to give it a standardized format. Right, that makes sense. So it's going to present it in a standardized format, whether that's going to be like a JPEG or however that is going to be presented. So that's what the presentation layer is going to be doing. All right, which layer tracks communication between the host and receiving computer? So that's going to be layer 5, and that's going to be the session layer. So when the session layer receives the correctly formatted data from the presentation layer, it looks to see if it can set up a connection with the other computer across the network. Okay, so then it's trying to set up that connection, trying to establish which protocols it's going to communicate through, and such. So let's go ahead and move on to the next one, and it's going to be this one right here. Which layer accepts communication requests from applications? And that's going to be layer 7, which is the application layer. Your application layer is obviously going to be accepting communication from applications. All right. So next, which layer handles logical addressing? That's going to be layer 3, as we know that's the network layer, and that's going to handle IP networking. When sending data over TCP, what would you call the bite-sized piece of data? So when it's being sent over TCP, it's going to segment that data, and that's going to be called a segment. All right. And which layer would the FTP protocol communicate with? And that's going to be layer 7, the application layer. So when you're thinking application, you're thinking about um, those end protocols, in this case FTP, that's going to be used to communicate. It's not like, for instance, your mobile application you have on the phone, it's in reference to the protocol that's being used. So FTP is used to transfer files. And so if you have an FTP application, let's say they've made quite a few in the past, usually like P2P type of things. You have a computer, transfers something to another computer, and it does that using FTP. So over port 21, I think I want to say like FTP Zilla or something of that sort. I believe I used to do that in the past, transfer files with FTP, but however, that's a little bit insecure. Nobody really does that anymore. Um, let's see. They still transfer through FTP, but I mean, um, if you can, you should do it securely, right? When transport layer protocols would be best, which transport layer protocol would be best suited to transmit a live video? So because you are transmitting a live video, if there's packet drops, that's okay. You're focused more on speed because you have time sensitive um, use, such as, let's say you're talking on the phone. Um, that you may not be able to establish a TCP connection. Instead, you're going to have to rely on UDP because TCP will make that end-to-end connection where UDP just kind of fire and forgets, it just sends it and throws it. And hey, if the other person on the other side catches it, great. It's like a quarterback just throwing a football and just throwing it, just throwing Hail Marys, and if it gets there, it gets there, right? So that's going to be UDP. We'll go to move on to the next task, task 3, encapsulation. So as your traffic or as your data is being passed down the different layers, it is being um, encapsulated, right? And as it goes up the layers, it may be getting decapsulated. And then here's the way that it's going about that. So when you're interacting with the application, um, and that data is then going down to the presentation, then down to the session, then down to the transport, right? And that's when it's actually sending the data and segments or through UDP, whichever it's going to be sending that data, and then it's going to go down to the network, and then that's when you're, you know, um, it's going to get that header so that your router knows where to send that to. And then next, it'll be getting a data link header. So that's going to be in the case that way your switch knows um, which interface to send it to. And then it's going to be encapsulated and it's going to be sent 1 zeros. And that's how that works. So next, how would you refer to data at layer 2 of the encapsulation process with the OSI model? So as we mentioned earlier, layer 2, that's going to be frames. So when it's being encapsulated, it's going to be a frame. That's what you're going to refer it as, a frame, right? If you're talking layer 3, that's going to be a packet. If you're talking layer 4, that's going to be a segment. And you've got to make sure that whichever layer you're referring to, that you're also referring to um, the encapsulation that that it's being processed as. Okay. How would you refer to data at layer 4 of the encapsulation process with the OSI model if the UDP protocol has been selected? So that's going to be datagram. So if UDP is protocol in use, then it's going to be referred to as a datagram. Okay. And if you want, you can go ahead and read into a little bit more details here. What you can do moving forward is use Control F, and you can even just type in datagram if you have trouble finding some of these answers. And you can see here, you can get some more details on why it's being referred to as a datagram. This is extremely helpful, especially when you're doing the other rooms. What process would a computer perform on a received message? So when it receives the message, right? So it will go about de-encapsulating, right? So it receives it as 1 zeros. It then begins decapsulating it until it gets to the actual data, which is the only layer of the OSI model to add a trailer during encapsulation. That's gonna be your data link. Again, it's adding that trailer to make sure that the data doesn't become corrupted, and if it does become corrupted, those trailers will help detect such corruption. Does encapsulation provide an extra layer of security? Yay, nay. So encapsulation does. Now, encapsulation alone provides security. However, you're going to want to have some type of encryption in combination with the encapsulation as well. Perhaps some tunneling. So now it's going through a VPN, and we'll learn more about this later. But that's a yay. Okay, task 4. Let's move. So let's see here the TCP/IP model, and so the OSI model that was created, but the TCP/IP model that was actually created by the DoD. And so the DoD, they just wanted to simplify it. So the application uh, combines the application presentation session, and then transport is a transport, and the network is internet, and network interface is going to be your data link and physical. And that can be a little confusing at first, especially if you ever see network interface, you may think network layer. However, if you see interface at the end, you know they're referring to the TCP/IP model. And the TCP/IP model is essentially it is the same. It is just a little bit shorter. Uh, all right, so here is how the computers are able to initialize a connection. And as mentioned earlier, TCP is a connection-based protocol. So whenever you have a TCP connection, it goes through this three-way handshake. And you'll hear about this three-way handshake a lot. So here you have your client, and it will send a synchronize to the server. So you kind of think of this like the client's going to it's going to request to synchronize with the server, right? And then the server is going to say, I hear you loud and clear, synchronize, acknowledge. All right. And then the client's going to say, acknowledge, roger that, right? And so they're doing this to ensure that the connection is received and acknowledged. Okay. And the way you can remember this is syn, ACK. Okay. But do remember that the syn, ACK for when the server is sending synchronize acknowledge occurs in the middle of that um, three-way handshake. Okay, so this has always become handy with me, especially when taking like CompTIA exams. They will typically you may have questions like that, like what is the three-way handshake? What are the how is the three handshake initiated? Like these aren't actual questions, but yeah, I'm trying to allude to the fact that this is going to be within the course material, and it's definitely something that you want to make sure you learn. It's very important because I want to see you succeed. I want to see you get all the certifications you need to um, be highly successful in cybersecurity. So which model was introduced first, OSI or TCP/IP? TCP/IP, um, so it looks like that one was introduced first. And which layer the TCP/IP model covers the functionality of transport layer of the OSI model full name? And so transport is going to be transport. Which layer of the TCP/IP model covers the functionality of session layer of the OSI model? And that's going to be application because application encompasses all three of those, um, application, session, presentation. Okay. The network interface layer of the TCP/IP model covers the functionality of two layers in the OSI model. These layers are data link and full name. So that's going to be physical, the network interface. If you remember, we went over that. It's a little confusing when you see that, but if you see interface, they're referring to the physical and they're referring to the data link. Which layer of the TCP/IP model handles the functionality of the OSI layer, network layer? So that's going to be the internet. It's going to be your network layer. What kind of protocol is TCP? It's connection based. So you have to have that three-way handshake. What is the SYN short for? That it's going to be short for synchronize. What is the second step of the three-way handshake? And that's going to be synchronize acknowledge. Okay. What is the short name for acknowledge? And that's going to be ACK. And whenever I see that, I always think Animal Akbar. All right, so let's go ahead and go over to task 5. And here they want us to do some pinging. So looks like what command would you use to ping this website? So, you just use ping and the website name. And then they want you to ping this website here. What is the IPv4 address? And if you ping it, this is what you should get. Now, I'm going to go ahead and open up my VirtualBox right now. I'm going to get logged in, and we'll try pinging it, and we'll see what we get. So they want us to ping this. So I'm just going to copy this, and then I'm going to come over here. And if you haven't already set up your own attack box, at the end of this video, I'll put a link for you. You can follow that link and I'll show you how to set up your own attack box so you can be super cool, super hacker, and you'll fit right in with everybody else. So let's go ahead and go ahead and ping. And I'm just going to copy that URL, or we should refer to this as domain name. Domain. All right. Ping the domain, and you can see when we ping it, it resolves the domain name to the IP address, and so then we get the IP address, and we can just now insert that here. What switch lets us change the interval of the ping request? So the -I will allow you to change the interval of that ping request, and let's go ahead and try that out. So -I 3. So right now I just did that. And you can see you can use this -I and then the interval, and you can see it's a little slower now than what it was at first. So what switch will allow you to restrict requests to IPv4? So if you want to restrict it, -4 will restrict it to IPv4. What switch would give you more verbose output? -V. And just for future reference, usually -V will always provide you verbose information. So it'll provide you more information than what you need. It's good for debugging, but usually, you know, you may choose not to use that. So we did verbose here. Let's say this aired out. It may provide more information than usual. All right, so that's great. Let's go ahead and move on to task 6. We're using traceroute. So traceroute, it's pretty great. It can be used to map the path of a network, and this can be very useful for like pen testing. You can kind of see where the firewalls are. You can see where it's being blocked. You can see the nodes between your victim and other nodes, which may help with proxy chaining and such. Some other stuff you'll learn later on, but you can see how that can be helpful. Can you see the path your request has taken? So it looks like they want us to trace route something here. So now it's your turn. As with before, all questions about switches can be answered with dman and page. Okay, so what I'll do is I'm just going to go ahead and Control C, and that's going to end that there. I'm going to type in clear. That's going to clear my screen. We'll then go ahead and, oops. All right, let's move this back over here. All right, so I'm just going to grab this command here. This is going to be the man trace route. I'm just going to quickly just paste it in. So let's go ahead and paste that in. All right, and when I do that, it gives me all this information here. I can press my space bar and just kind of go through it if I wanted to, but when I'm ready to quit, I'm just going to type Q and it will close out. All right, so what switch would you use to specify an interface when using trace route? So -I would be used for that. What switch would you use if you wanted to use the TCP SYN requests when tracing the route? So that would be -t, and then let me go and show you how you can check this as well. All right, so here you can see the -t, and if you read a little bit about it here, it says this method uses well-known half-open techniques, which if you remember earlier when we talked about the three-way handshake, um, if we wanted to use a half-open technique, that would be the -t, right? So lateral thinking, which layer of the TCP/IP model will trace route run on by default Windows? Okay, so that's going to be internet, right? Because as we had gone through earlier, internet is going to be IP, and that's going to be utilizing your router, right? And it's going to utilize the IP addresses of the systems to know where to route it. So that's what traceroute's going to be able to do, and it's a very useful tool, especially when I was an network admin. I used to use it, and it was pretty helpful whenever we need to find out, you know, which router was having issues or which router was down. All right, so let's go ahead and move on to task 7, networking tools. Whois? All right, so Whois here. So Whois is pretty cool. It allows you to gather information about the domain, and this is all public information. So let's see here. What are they asking for? Perform a Whois search on facebook.com. Okay, easy. And if you have Kali Linux, it's already installed by default. So I can just go here and quit that. All right, and we'll do Whois. And I'm pasting in facebook.com, and when I do that, it will provide me some information about facebook.com. All right, so here it's going to ask what is the registered postal code for facebook.com, and if you look through it, you should see that for the postal code. Let me go ahead and do a quick gaze and see if it's still there. Yeah, it's still here. So you got the tech postal code right there, and that's the answer. Um, what was facebook.com domains first registered? All right, when was it first registered? Okay, so let me scroll up here. Let's see if we can find that answer. If not, it is right here. I will also put this in the description of the video so you can easily and quickly answer these. Um, so if we go here, we can see that it was created, and then here's the date, and you can just input that there, but they want it by day, month, year. Here it looks like it's year, month, date. So may have to change that up a little bit. Perform a Whois search on Microsoft.com. So we'll go ahead and do that as well. Let's go ahead and just grab this, do a Whois search on Microsoft.com. All right, I did one on Microsoft.com. Let's go ahead and move over here. Let's see what we got. So no answers needed. Which city is it registered in? Let me see, register. And that's going to be Redmond. Redmond. So if you scroll through here, here it is right here. All right, great. And then OSNet, so Open Source Intelligence. What is the name of the golf course that is near the address? So I looked this up. This is the golf course here. That one was a tough one. I remember it's pretty difficult to look up. However, you can Google it, and we'll also put this in the description. What is the email? Okay, so if we go to the email here, you'll see. Let's see if they've changed it. It's possible they have. And this is a good reason to like and subscribe my videos because I provide you guys all the flags, all the answers, and I walk you guys through it. You'll find going through, Try Hack Me's beginner that a lot of the answers are misleading. They are not there, or you cannot find them on the internet easily. You'll always be able to find them easily in my videos, guaranteed. All right. So if you look that up anyhow, you should see that that is going to be the uh, email, and I see it right here. Tech email. Easy. Easy day. Task 8, dig. All right, so let's see what we got here. So DNS is the domain name system, and here you can learn a little bit more about DNS and how that can be used. Because computers don't really recognize these friendly names like google.com. They only recognize the IP addresses. So DNS is able to help in resolving that. So what is the first type of DNS server your computer would query when you search for a domain? And that's going to be the recursive server. And again, if you're having any issues finding this, you can just type in first here. We'll type in keywords and we'll try to look for it. And here you can see if they have recursive server in here. All right, we'll type in recursive to get more information on that. So assuming the address hasn't already been found, your computer will send a request that is known as a recursive DNS to a recursive DNS server. These will automatically be known to the router on your network. Many ISPs maintain their own recursive servers, but companies such as Google and OpenDNS also control recursive servers. So it may send it over to your ISP who has one or such. And so those recursive servers are able to most likely store the information and assist with resolving those IPs. So let's see here. We know that one. What type of DNS server contains records specific to domain extensions, .com, UK, etc. Those are gonna be your top level domains. Top level domains. So you got your like .com, .mil, .edu, and those are most likely gonna have that. Where is the very first place your computer will look to find the IP address of the domain? That's going to be your local cache. Usually the host file will contain the IP address of domains, um, especially if it's like an intranet or if it's something that your company knows you guys will be utilizing very frequently. They may put that in there, but usually has to be configured. But yeah, that's where it would go. Google runs two public DNS servers. One of them can be queried with 888. What is the IP address of the other? So that's going to be 8844 for the other Google DNS server. If a DNS query has a TTL of 24 hours, what number would the dig query show? So if it had a TTL of 24 hours, it would be 86400, and they talk more about TTLs here if you want to read about it. However, we'll go ahead and move on to task 9. So that's it, guys. We have completed this, and I hope you guys enjoy this video. Again, if you haven't already set up your own attack box, please watch this last video, and you'll definitely enjoy it. All right, have a good one. Danny out.